Okay, so just a quick recap. In last month's Forge DevDen, we invited Alex, who is a seasoned engineer from the Confluence team, to discuss how to build your own macro with the help of Forge. The event is a bit different from our usual time slot, wherein we live stream during the morning of the Americas region, which is around, if my math is correct, 1 a.m. Sydney time. So I still get confused with the whole daylight savings. So if you weren't able to join the event, you can check out the recording in this link that I will post now. There you go. So you can, this channel also contains the previous DevDens, as well as other event recordings like the recent Atlas camp in Belgium. So if you haven't subscribed to the channel yet, now's the best time to do so. Okay, moving on to what's in store for us in this session. So we have with us today the seasoned engineer and architect, Tim Peterson. So Tim is an ecosystem solution architect who helps our partners and enterprise customers be successful with the Forge platform. He was instrumental in building the platform itself during its early stages, which makes him knowledgeable about Forge, not only what's under the hood, but also about the patterns on how you can maximize the platform. While I still have a lot of awesome things to say about Tim, let's focus on today's session. So in today's session, we'll talk about different patterns on how one can integrate with external services using Forge. I know it sounds pretty interesting and exciting, but before I hand over the virtual microphone to Tim, let's go over some house rules first. So number one, unless you are asking or answering questions, please keep your microphones on mute in order to minimize potential background noises during the event. Second, if you have questions, please type them in the chat box and we'll get the attention of Tim by raising the virtual hand. And please feel free to ask them live. Normally, we save the questions towards the end, but we'll try a different format this time around. So if you do have questions, type them in the chat box and then we'll try to get the team's attention. Okay. Today's presentation is time boxed at 60 minutes. Well, maybe 55 minutes as soon as I finish talking. So in case you weren't able to answer, in case we weren't able to answer all the questions, please raise them in the developer community forums, wherein I'll share the link now. There you go. Okay, lastly, this session is going to be recorded and will be shared in the Atlassian Developers YouTube channel no later than the end of next week. So if you want to rewatch Team's awesome session or share it with your peers, you can visit the YouTube channel for the recording. So with that, I'll start recording now. Where's that? I always lose the record button when I'm speaking. Okay, I just hit the record button. And now I'll hand over the spotlight to our speaker right on time. Take it away, Tim.
Thank you, Ian, for the awesome introduction and for facilitating and, well, for inventing the DevDen. So for those of you who've maybe joined recently, Ian span up the DevDen at the end of 2023, I want to say. 2023. That's right. And it's become like a pretty damn awesome event. Now it's great to see lots of other Atlassian engineers and product managers involved as well. So thanks for having me back. So let me just share my slides. So as I had mentioned, I'm Tim. I'm an ecosystem solution architect at Atlassian. I'll tell you a little bit more about what that is because it's kind of a new function. Basically, my role is helping partners, like both marketplace partners and solution partners, and increasingly enterprise customers build apps on the Forge platform. As Ian mentioned, I've been around Atlassian for a while in our ecosystem department for the last decade or so. I was one of the founding engineers on the Forge platform and also in the original Atlassian Connect platform. So I've got a fair bit of experience building apps and platforms on and around Atlassian. And today I'm going to be talking about patterns for integrating Forge apps with external services, which is a bit of an unusual topic, given that Forge historically has been built as a bit of a walled garden where we put security and privacy first, and kind of make it difficult to integrate with services externally, unless you really need to. So Forge is Atlassian's hosted platform for app development. Hopefully, most of you know that. If this is the first talk you're ever seeing on Forge, it's probably not the best one to start with. Perhaps if anyone's in that bucket, Ian or Mel can share some getting started resources. Because today we're going to be focusing more on fairly advanced or moderately advanced patterns for integrating Forge with remote services. Now, as I mentioned, Forge is by default a walled garden. By default, you can't make requests outside of the Atlassian network. It's also tenant isolated, so a Forge app can really only make calls back to the Atlassian product that it's installed into for the customer that triggered the Forge app in the first place. This means you can't make network requests out to the public internet without specifically declaring that you need to inside of your app's manifest. Now, if you do this, the administrator of the Atlassian product that you're installing the Forge app into will be notified when they install your app that it needs to share data outside of Atlassian's cloud. Now, despite that, a lot of Forge app developers do end up needing to integrate external services into their app in order to achieve their intended use case. So in some cases, developers might need to use external APIs that are not provided by the Atlassian platform. So for example, sometimes you'll need to use something like SendGrid or Amazon SES to send emails. Or if you're implementing a telephony solution, you might need to use Twilio to accept voice or send SMSs. Or if you want to imperatively call LLMs, we don't provide a direct API for doing that in Forge today. So sometimes you'll need to call out to ChatGPT or Anthropic in order to be able to to do AI stuff. Another common pattern that we see is when we have other SaaS vendors who've built a product that's a standalone product that they sell themselves outside of the marketplace that they want to integrate with Atlassian. So if you're building an integration in cloud, occasionally you'll use our OAuth 2 protocol in order to be able to integrate them. But if you want to serve user experiences inside of Atlassian products or consume events from Atlassian products, then typically you'd use Forge with a Forge remote integration pattern, which we'll look at a little bit later in this presentation in order to be able to integrate them. We're also seeing an increasing number of customers who install on-premise tools and services in their data center, but are using Atlassian Cloud's products, need to use some of these patterns in order to integrate Forge with their services. And then finally, if you're a Connect app developer in the process of adopting Forge, you may need to use some of the techniques we're going to talk about today to integrate with your Connect app backend. So a lot of the content from this talk was actually inspired by a presentation that I gave at Atlas Camp recently, which was our developer conference in Brussels. If I saw you there, good to see you again. And so you can also use a lot of these patterns for integrating with your existing Connect backend when you're building new features. So if you've got if you're building a new Rovo agent, for example, or a new Jira custom field, and it needs to fetch data from your Connect backend, you can use some of these patterns in order to be able to achieve that. So to start out, every Atlassian plugin system has a concept of modules. Now, in Forge, these are defined in your app manifest, and that's where you declare the extension points that your app implements. With respect to integrations, basically any Forge module can be integrated with a remote service, and there are 4 general patterns for how you might do this. The first is to implement new modules natively as Forge functions without sharing data externally, which is what the platform was originally optimized for. This works great if you want to build an app that doesn't depend on external APIs. And if you're aiming to build an app that's eligible for the new Runs on Atlassian program that we've been previewing with our ecosystem, then you'll need to build all of your apps modules in this manner to be eligible for it. The second approach is to implement new modules using a technology called Forge Remotes. So a Forge Remote lets you access an external web service as a backend for your UI modules. or it allows you to externally process Forge events emitted by the Forge trigger module. And I'll talk a little bit more about how Forge Remote works in a little bit. This particular pattern is especially relevant for developers migrating over from Atlassian Connect, because if your app is built on Atlassian Connect Express or Atlassian Connect Spring Boot, you're actually already running for a Forge Remote service, because all modern versions of our Connect frameworks have built-in support for the Forge Remote protocol. A third approach, and this is actually the approach that I typically end up recommending when we talk about using remote services, is to implement new Forge modules in a hybrid fashion. So this means binding a Forge module to a Forge function, just as if you were going to implement natively, but then calling out to your remote service when you need to access additional data or functionality using Forge Remote. Now, in practice, the reason this tends to be what we end up recommending, rather than directly binding a module to a remote endpoint, is because it lets you use other Forge platform features from within your function, and it does give you some finer grained control over how and when your backend remote service is invoked. We'll talk a little bit more about that in a tick. And the fourth and final approach is the approach that we've supported in Forge for quite a long time, since prior to remotes, where you procedurally specify a set of domains that your app needs to egress to. This is a little bit simpler than remotes, and it is useful in particular where you're not operating that remote service yourself. Now, the reason for that is with a Forge Remote, we sort of take over the authentication system for you. So we apply an authorization header on the outbound request when you invoke a remote. Whereas if you need to control the authorization header yourself, then the only real way to do that is to use egress controls instead. So if you're integrating with Twilio, as I mentioned, or using OpenWeatherMap or OpenAI or any other external service that you don't own, then you'll need to use egress controls to go through the Forge egress proxy instead. Now, the best approach to take for implementing a given module depends a little bit on the nature of the integration that you're building. Now, before we look at patterns for implementing individual modules, I'm going to give you a quick primer on the Forge Remote protocol itself. Now, if you're familiar with Atlassian Connect, Forge Remote is conceptually similar to Connect's JWT-based authentication and authorization scheme, but it differs in a few important ways. So in this scenario, we're going to use a remote called Connect that's defined inside our manifest alongside a base URL. As I mentioned before, if you're using a Connect framework, it already supports Forge Remote. However, the Forge Remote spec is pretty straightforward and a remarkably well documented piece of infrastructure as far as the Forge docs go. So you can pretty easily implement your own Forge Remote server for natively built Forge apps as well without using Connect. Once you have a Forge Remote defined in your manifest, you can use the invoke remote function to make requests to paths that are served underneath that remote's domain. So when the Forge platform invokes a remote endpoint, we send a thing called a Forge invocation token, or a FIT, as an authorization header for that request. Now, while they're kind of similar to Connect's JOTs in a few respects, a FIT is a little bit different and has a few different advantages. The first is that the Forge invocation protocol is stateless. So when you make a request to a remote, we generate a signature that gets applied to your FIT using a private key that's housed inside of the Atlassian platform. And then you can verify that token using a public key that we publish in a well-known spot in the, it's basically a file called jwks.json that sits on a public CDN. Now, the advantage of that is that you don't need to store a shared secret or any other credential in your remote service in order to be able to verify these requests from Atlassian, which is pretty neat. The other thing that's kind of handy here is that these tokens are quite short-lived. They're only valid for a period of 4 hours. So it does massively increase the security posture of operating a remote service versus something like Atlassian Connect, where you have to store very powerful shared secrets. The other nice thing about being stateless is you may not even need a database for your remote service. So if you're doing something like PDF rendering or any other, or if you're hosting your own LLM, for example, and you need to be able to make requests to that LLM from a Forge context, unless you actually need to store some state associated with your app's functionality, you can potentially not even have a database associated with that remote service. You can just pass all of the context that you need from your function into your remote service, process it, and then return that response back to your Forge app. Now, the Forge invocation token contains a bunch of context. Won't go through all of what's available there. But the idea is that it passes everything that you need to know about where your app was invoked from, and the context of the user and any other information about the extension point that triggered this invocation. So you can see your Atlassian site, the app that triggered this remote. So you can use the same endpoint for multiple versions of your app if you like. And you can also have, it also specifies the module that triggered the invocation. Now, one small note for developers coming from Connect, you've noticed that one critical thing that is missing versus requests from the Atlassian Connect framework is the client key. So in Connect, we use the client key as the primary identifier for the site that your app is installed into. In Forge, we've actually replaced the client key with two separate identifiers. One of these is the Cloud ID, which is down the bottom there. So the Cloud ID identifies the site that the app is installed into, and it's stable across all of the apps that are installed into your site. One pattern that's come up a little bit from marketplace partners is where you have two different apps from the same partner, and you want them to be able to interoperate with each other. So if you are, one way to do that is to have them talk to each other via Forge Remote. And if you're doing that, you can use the Cloud ID to figure out like which two apps are installed into the same site. We also pass a second identifier called an installation ID, which has slightly different semantics around it. This is a unique identifier for the installation of your app in that site. So if you uninstall the app and then reinstall the app, that installation ID will be cycled. So it depends a little bit on your exact use case and what sort of data lifecycle you want to have if you're storing data outside of Atlassian as to which one of these identifiers you want to store. Generally speaking, if you're not sure, to be future-proof, it makes sense to kind of store both of them as like a composite identifier for any information that you're storing inside of your app. The Cloud ID is also available to get on demand from any Atlassian site. There's like this special secret but public stable API called that sits at _edge/tenant_info. That will return the Cloud ID for any Atlassian site. That can be quite handy if you have a base URL for a site and you're trying to figure out what the Cloud ID is. You can use that to back reference there. Okay. The other thing I was going to say is if you're like screenshotting stuff, like feel free, but I'll share a PDF with the slides at the end because there's a lot of diagrams that we need to go through and lots of boxes and lines. Otherwise, as Ian mentioned, there'll be a recording that we'll publish very soon. So there's a few different ways you can invoke your remote service from Forge. You can call it imperatively from a Forge function using the invoke remote package that we looked at before. You can also invoke remote from the front end if you want to use your backend, if you want to use your remote service as a backend for your Forge functions. For your Forge UI modules. Or for many modules, you can skip the Forge function entirely and specify an endpoint that references a particular path under one of your remotes. There's a separate module called endpoint you can declare. And then you can bind your Forge modules directly to that endpoint instead of binding it to a function. So if you do this, it means that when your module is triggered, we'll send the payload directly to your remote endpoint instead of passing it to a Forge function. Now, in some cases, your remote service may need to call back into the Atlassian product APIs. So Forge Remote also has a mechanism that allows you to request bearer tokens that let you authenticate with any Atlassian API that supports OAuth 2. And these bearer tokens also give you access to Forge-specific APIs, such as Forge Storage. So even though you're not storing credentials externally, you can still request a token that lets you authenticate back into these APIs, which is pretty nifty, really. So for added security, we don't send these bearer tokens to your remote by default. You have to specifically ask for one by registering for it in your manifest. To register to receive a bearer token, you just add a little auth section where you declare your remote. And there are two different types of auth tokens. One is called an app system token that allows you to authenticate as your app's service account or your bot user. And then there's an app user token as well, which means when your Forge app is invoked by a particular user in a user context, then we'll also pass a user token to you as well. So you can impersonate that user when you're making a request back. Oh, sorry, Ian, is there a question?
Yep, sorry to interrupt. I kind of missed this one a while ago. It popped up in the Q&A widget. So the question goes like, can the egress be an ATL product, Cloud API? That's from Ulrich.
So any sort of like HTTP based API can be declared as a Forge remote or defined as an egress role. The reason it has to be an HTTP based API, so like REST or GraphQL, is that the request goes via the Forge proxy. So there's like a proxy that sits between your Forge app, which is essentially like an AWS Lambda function with some stuff glued on top of it. And then there's a proxy that sits between that and the public internet. And then so that proxy will enforce the like egress rules that you have defined inside of your app manifest. So as long as it's an HTTP based or web-based API, then that's totally fine. Cool, great question. So once you've registered for those bearer tokens, we'll start sending them to your remote service as a separate header or two headers if you're registering for both. Every time Forge sends you a fit signed request. This means that you can then use these tokens to authenticate with those product APIs or the Forge REST API, and they'll have the same scopes as your app declares. As I mentioned, these tokens are relatively short-lived, so they last for a maximum of 4 hours. If you need to be able to make API calls back to Atlassian at any point in time, there's another pattern I'll show you a little later where you can use a scheduled trigger to refresh those tokens on an interval. But we'll get to that in a sec. So now that you've got a bit of a handle on the Forge remote protocol, let's look at some of the patterns you can use to implement Forge components using remotes. So in this section, we're going to look at a few different things. The first is eventing and how you can integrate Forge event triggers with remote services. The second is we'll look at patterns for using queues and async functions, where you might need to do some of that processing off Atlassian in your own remote service. And then finally, we'll take a little look at that pattern I mentioned around using scheduled triggers to refresh health tokens. So in Forge, if you haven't used them already, a product trigger is conceptually similar to a webhook. Basically, it lets you subscribe to events like issue creation or page deletion or comments, or it lets you subscribe to app lifecycle events like installation or uninstallation. And then whenever one of those events occur in a site that your app is installed into, the corresponding trigger module will be invoked for your app. Now, in a native Forge app, triggers are bound to functions, and we marshal up an event payload and some context, and then pass that as an argument to your function where you can process it using JavaScript. Now, in a remote world, you can integrate a product trigger with a remote service using that invoke remote function. Or, as I mentioned before, you can also just bind it directly to an endpoint, which will skip the Forge function entirely and pass that event directly to your remote service for processing. Now, this is kind of the simplest way to get data out and consume events. But I'd argue that it's often a better idea to use a Forge function to give you some finer grained control over how these trigger events are set. Now, one reason is that you may want to do some processing on the event before you send it to the remote. And one of the key differences as well here, if you're used to connect webhooks or registering webhooks directly via Jira administration, is that Forge events are quite anemic by design. So we've designed them to be as performant as possible and also not leak crazy amounts of data. So by default, a Forge app will have no user display names. You'll be able to get the account ID, and then if you need additional user information, you can go and fetch that from the API. Whereas if you look at our traditional webhooks, they've got pretty verbose representations of data objects. If you've ever consumed like a Jira issue created or updated event, you'll see like a ton of custom fields information, and often that custom field information is just null. So it's like a crazy amount of data to send over the wire for not much value. So Forge events tend to be much more anemic and then only include that core information and some identifiers that let you look up additional context via REST if you need to. The other big difference, particularly versus Connect, is that we've changed the way that event filtering works in Forge. So in Jira, if you've built an Atlassian Connect app that consumes webhooks, you can filter it or filter which events are actually sent to your app using a JQL query. In Forge, we've actually implemented this filtering functionality using the more versatile issue expression language, which are called, issue expressions, which is that'd probably be a good topic for a dev den at some point. It's a super powerful language if you haven't used it before, super fast, but it's not JQL. And so if you did want to test an event against a JQL query, then you can't do that directly in a Forge product trigger today. Another subtle but quite important difference is that retries work quite differently in Forge. So in Connect, and I believe in the core product, we attempt to resend a webhook up to 5 times with a random interval between 5 to 15 minutes each time. So this means that if your Connect app or your remote service that is consuming the event is down for more than 5 times 5 minutes, so 25 minutes, then you start to run the risk of missing webhooks, because at that point, we'll just drop those events on the floor and not re-emit them. Now, a Forge function has a slightly different approach here, where you can retry up to 4 times. And the way you do this is you can actually throw an exception in your Forge app, in your Forge function saying, hey, retry me after X period. And that's configurable up to 15 minutes. So that means you can suspend event processing for up to an hour. However, if you define an endpoint as the target of a Forge trigger, then it will retry up to 4 times with a fixed interval of 60 seconds. So by default, if you use an endpoint directly bound to a trigger module, then you only have 5 minutes before you may lose an event if your remote is down. So using a Forge function, actually, we'll get to that pattern in just a sec as to how you can work around that. So one way to overcome some of the differences in event processing between Jira's core webhook processing and Connect and Forge is to use a Forge function to mediate passing the event to the remote rather than specifying an endpoint directly in your manifest. So in this way, you can, for example, attempt to call the remote using invoke remote. And then if that connection fails for whatever reason, or if you get back a non-200 status code from the remote service, you can throw a retry exception from your function, and then Forge will retry your trigger, and you can retry the remote request. And that means you can suspend these requests for up to an hour if you need to. The other thing you can do is implement more complex filtering inside of your trigger function. So if you want to limit the amount of remote processing logic you have in your remote service, or limit how many requests you send over the wire, you can implement your own filtering inside of Forge. So for example, you could go and replicate Connect's JQL filtering if you like, or you can have any other criteria where you can drop events inside of the Atlassian Cloud rather than emitting them remotely. which is kind of nice because often our event system can be fairly chatty. If you've ever like had a project deleted event or like a bulk edit, you'll know that you get quite a large number of notifications when that occurs. And then you can also use the Forge function to hydrate the event with additional data before making a request out to your remote service. So if you do need to go and fetch custom field information or linked issues or user information, then you can go and call back into the product APIs. So this also takes advantage of Forge's automatic authentication because you can just use request as app to go and fetch that data. And it also allows you, it also takes advantage of the fact that Forge functions are much closer to the product APIs than the typical external service that you're hosting yourself. And so that means that you should have better latency calling from Forge rather than externally. And it also, yes, right, and it means that you don't have to call directly from your remote service into the product. Now, the other thing you can do if you want to make your service really resilient is beyond just like throwing an exception to your trigger module, back to the Forge framework, which will allow you to suspend event processing for up to an hour. You can also push it to a queue. So we'll talk a little bit about queues and consumers in a second. But if you want to like buffer your Forge your events into a queue and then have a queue consumer call your remote instead, then you can potentially like persist those events to Forge storage if your remote service is down for an extended time. So if you really, truly, absolutely do not want to drop events, then you could potentially go and store those rather than just sending them when the Forge platform gets them. Now, speaking of retries, there's one particular context in Forge to be aware of where this is like actually critical to do. So Forge has a installed trigger event. Now, one of the gotchas with the installed event is that it may fire before your app's permissions are initialized inside of the product that is being installed into. I'm pretty sure the same thing actually happens with the Atlassian Connect framework as well, but it's a bit of a sort of Heisenbug because, well, sorry, it can lead to Heisenbugs in apps because often you won't notice this if you're testing your app in a relatively small site. And you'll run into this problem if you install your app into a very large site that has lots of like Jira projects or Confluence spaces. And this is because under the hood, when your app is installed into a site that it hasn't been installed into before, we have a permissioning service that goes off and grants the appropriate permissions on all of the domain objects in that particular site. And in particular, Confluence can be quite slow. So if you've got like tens of thousands of spaces, then it can take like minutes for your app's service account to get all of the appropriate permissions. So if inside of your installed event, you need to go and do some setup that requires calling into the product APIs, and particularly anything that involves working with like spaces or projects, there's a chance that calling as app.request Jira will fail with a 401 or a 403 or request Confluence. So one important thing to do in an installation event, and this is actually, we've actually updated the documentation to have this pattern documented. We've seen a couple of partners run into this. You should make sure that you're trapping 401s and 403s. Even when you're requesting the appropriate scope, and you should always have those permissions, and then throw an invocation error with a retry, retry delay and a retry reason. Now, the amount of time it can take for those permissions to be allocated does vary based on the size of the site. So I usually recommend an exponential backoff here, and this is the same example I've put in the docs, just to keep backing off until those permissions are available. Okay. Speaking of queues, let's chat a bit more about how you can use them in a hybrid Forge and remote world. So we talked a little bit about them on a previous slide. If you haven't used a Forge queue before, we actually refer to them into the documentation as async functions. A queue consumer and an async function are exactly the same thing. Basically, it's very similar to an AWS SQS queue. In fact, we use SQS under the hood to implement them. In your manifest, you define a queue name and a consumer function, And then that function pulls jobs from the queue and processes them. So any function that you have deployed can call or can add new jobs to the queue using that little code example we have there, queue.push. And then you can basically your consumer function will be pulling those jobs from the queue and then processing them. So we don't support specifying a Forge remote endpoint directly as a consumer, but since a consumer function is just a regular Forge function, you can still push these jobs to a remote using from your Forge function using that invoke remote function that we looked at before. And then a Forge remote also can't directly push jobs to a queue. So we don't have like a public queue API that you can call from your Forge remote. But you can work around this by using a Forge web trigger to push functions to the queue for them. So Forge web trigger functions can push to queues just like any other function can in Forge. If you haven't worked with web triggers before, they're basically a mechanism for exposing a Forge function as an HTTP endpoint. So just like we've got a proxy in Forge that mediates any requests out, the only way you can make a request into Forge, or specifically to call a Forge function, is by exposing that function as a web trigger. So you can use web triggers to basically build like an external API for your Forge app, or I'll use this to ingest data and webhooks from external services. So if you're integrating another SaaS app into Forge, then or if you're integrating like an on-premise tool with Forge, then usually you'd use a web trigger to ingest data. So they're like, while we don't let remotes directly call Forge functions, these web triggers are a pretty decent workaround to allow your remote service to invoke them. Now, async queues have a few gotchas associated with them. One is that, well, actually, this is less of a gotcha. This is more of an awesome thing. Queue consumers have extended timeouts. So if you haven't used async, actually, maybe I'll pause for a sec. Was there another question, Ian?
Yep, there is, but I'll let Ulrich ask the question live if to make it more interactive.
Yeah, go for it.
Hi, Tim. So good to see you back. I had a question. Web triggers, do they support GET requests? Because last time I checked, they didn't.
Yeah, absolutely. So I think you can hit them with basically any method type, and then it's exposed as like a property on the context object that gets passed in. There is a little bit of a limitation with web triggers though, where you can't currently change the path of a web trigger. So there is like you couldn't implement like not a single page app, but like you couldn't have like a set of different routes that are mounted on the same web trigger. But certainly different method types is fine.
Thank you.
No worries. So yes, as I was saying, one really common benefit of using an async event is that they have an extended timeout. And we've recently increased this to 15 minutes. So in your manifest, you can actually specify a timeout seconds property as part of your function definition, or sorry, as part of your async function definition that will let you extend it up to 900 seconds or 15 minutes, which is much more than the typical timeout, which is 25 seconds. By default, if you don't configure it, I think the default is 55 seconds. But if you have like a longer running task, then this can be a great way to extend that function timeout. And there is also a way to check the time remaining using the invocation remaining time in millis property that's available in the app context. Now, the gotcha is that queues maybe and usually are processed in parallel. So if you have multiple jobs pushed to the queue or multiple events pushed to the queue, then we'll basically spin up multiple versions of your consumer function and consume those events. And because that's happening in parallel, there's no guaranteed ordering of the event processing either. So this can be a bit confusing. You can also run into problems with things like product API rate limits if you're assuming that your queue is going to be processed in a serial fashion. So there is a pattern you can use to guarantee ordering on Forge. We don't natively support like a FIFO or like a first in, first out queue, but there is a technique you can use instead of pushing multiple events to the queue, what we've seen some partners do is serialize all of the jobs into a single payload, and then passing that as an array as a single job on the queue. And then you have a consumer that pulls that payload, pops one event off the stack or off the array, or shifts in JavaScript, and then, or unshifts rather, processes it, and then pushes the rest of the events back onto the queue. So this guarantees there'll only ever be a single job processing a particular set of events, or a particular array of jobs rather. And you can still push multiple arrays and have like multiple sets of consumers processing those different arrays, but each array will only be processed by a single consumer at a single time. Now, one thing to note is there's a couple of limitations with this approach. The first is that you can only push a maximum of 200 kilobytes to the queue in any given invocation. So if you're processing more data than that, then you may want to store that data in Forge storage and then pass an identifier on the queue instead. And so the job basically reads out that event and then processes it, and then passes the rest of the identifiers on. The other thing you might run into here is this pattern of a consumer pushing back onto its own queue creates a cycle. And so basically the consumer pushes back, this triggers another consumer, and then that triggers another consumer, and so on. Forge actually has a cyclic invocation breaker that prevents like a runaway app from accidentally like exhausting queue resources and taking down Forge. So for async functions, we have this cyclic invocation depth limit of 1,000. So this means in practice, if you implement this pattern, you can have like a maximum of 1,000 consumer invocations in that cycle before Forge will just stop. So in practice, this means if you use this pattern, you can have a guaranteed execution order for up to 1,000 items. Now, there are other patterns for handling over 1,000 items. So for example, you could process more than one item in each consumer iteration. So the consumer can be have a timeout of up to 15 minutes. So you could basically just keep shifting items off that queue until you get close to that invocation timeout, and then you push the queue back on the stack. Or if you want to have like a support for a, not completely unbounded, but a very large number of items, you can, instead of using an async function queue to store the events, you can instead use a scheduled trigger and serialize the entire queue in Forge storage, and then just pull out events and process them in order. I won't go into those into a lot of detail for those today, but happy to chat more about one of those patterns if you need some support later on. So we've talked a bit about event triggers and async functions. I'd like to touch quickly on scheduled triggers. If you haven't used these before, they're a mechanism that allows you to invoke functions periodically. So we support invoking weekly, daily, hourly, or relatively recently we rolled out support to have a 5-minute interval as well. So just like other functions, schedule triggers can interact with your remote service using invoke remote, or you can actually bind a scheduled trigger module directly to an endpoint, and we skip the functions and just call you directly. I mentioned before that usually I recommend going via a function so that you can have more control over invoking a remote service. This is a particularly good time to use an endpoint for one particular use case. You might be thinking, okay, why would I need a schedule trigger? I can run cron in my remote service. I don't need Atlassian to call me once an hour. I can do that myself. One reason this is quite useful is that you can use a schedule trigger to basically get us to send you auth tokens that you can then cache and use to make calls back to the Atlassian APIs at any time. So if you in your schedule endpoint specify an auth section with either a system token or a user token, well, actually, sorry, only a system token. We don't support user tokens in this context because a schedule trigger runs outside of a user context. It's just being authenticated. Sorry, just being invoked as the system user rather than as a particular user. Then we'll send you. I'd usually recommend doing this hourly. We'll send you a token that's valid for the next 4 hours. So you can basically cache that and call back into the product APIs or call back into Forge storage at any point in time. And because that token's short-lived, it's only valid for 4 hours, it's still more secure than having like a permanent, long-lived shared secret or other credential. All right. Sorry, that was quite dense. Thank you all for hanging in there, and thank you for the great questions there. That's all the content I've got for today, but I'm happy to share the presentation. Actually, let me see if I can do that now in a PDF. Hold on. Hold on. Just find the chat. Okay.
Okay, so while waiting for Teams upload to finish, does anyone have any questions? Okay.
Tobias?
Hey, morning. I was hoping you would also touch a little bit on external auth. And since this is apparently not happening, I was wondering if I could ask a question about that anyway.
Of course. Yeah, for sure. Sorry,
Okay.
I ran a little long on the content side of things, but I might just introduce what external auth is just for the rest of the audience, if that's okay. So alongside Forge Remotes and Forge Egress controls, you can also use a feature called external auth that uses our built-in authentication providers to authenticate requests out to external services. We have a few different baked-in auth providers, but basically, if a remote service implements three-legged OAuth for OAuth 2, then we'll handle the client side of that OAuth dance with your users. Actually, let me kill this slide sharing for a second. And so that means if you say you want to call like a Google API, for example, and you declare an external auth section in your manifest, then use our external auth client APIs inside of your function, then when you attempt to make a request to that external service, if the user hasn't already authorized you, we'll put that user through the three-legged OAuth dance with that OAuth provider and then store the token on behalf of that remote service. So that means that you, as the app developer, don't have to directly manage those tokens. Happy to chat more about that. But yes, no, thanks, Tobias. What was your question?
Right. Yeah, thanks for that. I was wondering actually, so external auth is great for making calls to external services. However, some external services that some of our existing apps integrate with also like to make calls back to our apps. And I'm considering during this whole Connect to Forge move, how I would, or like the best idea I can come up with is that I have like a separate service that we still host that like Forge apps register with during installation. So that then the Forge apps have like a web trigger URL that they register with our centralized service. And then if that centralized service is called for a certain tenant, we forward that request to the web trigger, for example. So
Yeah.
that's like the best I can come up with. I was wondering if you had any, if
Yeah.
you had thought about this scenario and if you had any different conclusions than I have.
No, so the way you're describing it is exactly the way to do it today. So at the moment, web trigger URLs are all tenanted. So it's like, as you mentioned, you've got to do that tenant mapping off Atlassian in your own service. We realize that's unfortunate, and we have discussed the idea of having like a app scoped web trigger URL, so you could do that mapping on the platform instead. I don't think it's on the short-term roadmap. I can go confirm that, but yeah, we would like to have something like that at some point, so you can implement that sort of pattern. You could, well, it depends. So you could map it to web triggers, or if you're building a remote service anyway, you could use Forge Remote for that web service instead, which is handling the proxy, and then use the listen to the Forge installation event, and then store that mapping for your remote at that for that tenant at that particular point if you wanted to avoid using the WebTrigger URLs. But then you'd still need to cache those external tokens. Just that the thing with WebTriggers is you'd need to implement some sort of auth scheme yourself. So yeah, unfortunately, short answer, no, there isn't a great platform solution for it, and I think you're definitely taking the right approach there with what you're looking at doing.
All right, thanks.
No worries, Tobias.
Okay, thanks. Any other questions? There's one in the chat from Christian.
Ooh, that's a good bit of feedback, Christian. So Christian's saying that the cyclic invocation limit doesn't allow a depth of 1,000 invocations as currently documented, but a total. So if you push 10 events to the queue to be processed in parallel, each of those invocations can only push 99 events each. Huh. Okay, thanks, Christian. I'll go raise that with the team because agree, that's not how it's currently documented. I think in practice, for that pattern that we looked at, let me share my screens again. This is why I love DevDen, because there's always awesome partners who have gone and attempted some of this stuff in anger and then run into problems in production. So let me just share that screen where we're looking at it. So basically the documentation states that there's like a cyclic depth. So basically the same event, or the common interpretation of the documentation would be if you have a consumer that consumes an event and then that consumer pushes back onto the queue and then that same event is consumed again, then eventually you get to a depth of 1,000 and Forge falls over. But what Christian's saying is that if you have two different event queues, two different events that are pushed to the queue, and so two different sets of consumers that are consuming events in parallel, then you'd only have the ability to process 500 events. So I think for this pattern, you'll be okay as long as you only ever have one event on the queue. So if you're doing it to do a big batch process of something when you're first initializing your app on your site, then it's probably okay. But if you're using it to process different jobs or sets of jobs, then you may need to be a little bit more careful about sizing those jobs. In which case, spilling over to store them in Forge storage or some set, and then using a scheduled trigger to process the queue, rather than having the consumer invoke itself is probably a better pattern. Thanks, Christian. That's a great bit of feedback. I'll follow up with the Forge team and make sure we document that better and have a better pattern exposed there.
Cool. Thanks. Okay, we still have 5 minutes for Q&A. Otherwise, I'm going to give 5 minutes back to everyone.
Well, thanks a lot, folks, for turning up again. And I'm so sorry that we had to reschedule from last week. It's always a ton of fun to present to you all. And hopefully I'll see some of you at Team in a few weeks' time, like 2 weeks, 3 weeks' time. If you have anyone in your team who's attending, Ian is running an awesome session on developer training at Partner Accelerate the day before Team, and then also another session during the conference, which is definitely worth checking out. It's awesome content, particularly for if you've got junior team members. It's a very zero to hero style piece of content for new folks. And there's also some material in there that I'm sure seasoned folks will get something out of as well. But thanks very much, Ian and Mel, for hosting. Round of virtual applause, which will be screened out by Zoom's filter.
Thanks.
Yep, thanks everyone. And thanks, Tim, for imparting your knowledge with us. Thanks to the attendees for spending your morning/afternoon with us. And I hope you learned something new today that you can take back with your respective teams. So with that, I guess, bye everyone, and hope to see you in the next Forge DevDen. Cheers.
Thanks, folks.